So scatter plots are graphs that use points to display some kind of data with two variables or whatever. So what do you think about those things? To display what? That's not a B. Bivariate data. That's data with two variables. Okay. And that data needs to be numerical. If I can spell. Okay. So it's numerical data with two variables, or something we call bivariate data. Scatter plots can help determine if one variable has an effect on the other, or if there's an overall trend, pattern, or correlation between the variables. Correlation. Okay. So basically we want to see, do the two variables have anything in relationship to each other? Okay, that's what we're looking at. So Zara surveyed shoppers at a mall to see how many items they'd purchased and the total amount of money they'd spent at the mall. And so she created this data over here based on that. Number of items is in the X, total money spent is in Y. So how many people did she survey? How would I do that? How would I find out that value? Just count them up. So how many dots are there?
16.
16 dots. Okay. And then does the number of items purchased seem to have an effect on the amount that people spend? Does it look like there's a general trend that the more items you purchase, the more money you spend? Does it look like that's generally true?
Yes.
Yeah, it sort of looks like it's going, like it looks like your data is kind of shaped like that. Right? So, yes, it does look that way because the data seems that as X increases, Y increases. Yeah. Okay, so it seems that there is some sort of correlation. So this correlation, if you were guessing, would you think that would be positive, negative, or no association for that one that we just looked at, if you were guessing? Positive, because you can see that it matches this piece down here, right? Bless you. Okay, it's moving that way. So as one variable increases, the other variable increases. That's what it means for a positive association. In this case, I use the word association. I use the word correlation, but similar idea. And in this case, the variables change in the what direction?
Horizontal, vertical.
Yeah, we'll go with that. I was gonna stick with the variable instead of in the Y or X direction.
Both. Y.
Yeah.
Oh, yeah.
In the Y direction. Okay. As X gets bigger, Y gets bigger. Okay. Now, negative is the exact opposite. As our X variable increases, our Y variable decreases. And once again, it's important to remember these things happen because we read things from left to right. Right? If we had read this from right to left, it would be the opposite, but we don't. Okay, so the variable changes in Y direction again. And then the last thing is the change in one variable has no effect on the second variable. This might be something like the number of TVs somebody has and how often they brush their teeth. Right? Those two things are not correlated at all, right? It doesn't matter how many TVs you have. That's not going to determine how many times you brush your teeth a day, right? They're not connected. So you would expect there to be no correlation. So try number 1, 2, and 3. Just based on the description, try to write positive, negative, or none, just based off what it says. So just give it a shot. I'll give you maybe a minute to try, and then we'll go over them. And the key part of this is explain, because you might be able to make a explanation that makes it one way or the other. Okay, what do you think about the number of shoes a person owns and the number of states they've visited? Okay, why?
Because they have no idea.
Okay, well, I think I'm going to argue that there is an association, because if you can travel to a lot of states, you might have more money, and more money may mean you have more shoes.
But then again,
Right? So that's what I'm saying. The explanation may be important here. Now, you could be right. It could have nothing to do with each other. The graph could look like this. Okay?
Because the person could also just not like shoes that much.
Sure. I mean, that's totally true. But if you look at people who have massive shoe collections, they generally have more money than people that don't, right? But it could be like this, and it could be no association. Okay, what about the size in ounces of a steak and the cost of the steak? Right? So, in general, like at different places, the steaks may cost different amounts, but the smaller it is, the less it's going to cost, and the bigger it is, the more it will cost. Okay? What about number of days since watering a plant and the moisture level of the soil? Because the moisture level starts off at a really high moisture level, and then as time goes by, with maybe we have 12 different plants, I don't know. As time goes by, the water evaporates from the soil and gets used by the plant, so the moisture level goes down. Okay? So we've got no correlation, sort of a positive correlation, and sort of a negative correlation. Okay? Now, this next thing is what we were mentioning yesterday about how strong or how close it is to that line that we looked at. So if data points are close together, the association is strong. If the data points are widely spread out, the association is weak. Okay? So if we have a lot of data, and I'm just going to draw that line. So maybe that trend line, which we'll talk about later, looks like that. Maybe this one looks like that. You can see that these things are more close or closer to the line than these, and there's more of them. So the more data you have, the more accurate your information will be. So if I had even more data, all these blue dots as well, right? Then that would mean that that's a very strong chance that that trend line accurately displays the data. And we'll talk about that again later. So if a straight line can be drawn to show the trend, the association can be described as linear, as a line, linear. That's not how you spell that. Linear. And you can see that this can be, and this doesn't make sense if it's a line, right? The data does not show a line, it shows more of a U shape, right? And something like that might be height over time, right? I don't know, this is maybe a bad example, height over time, but you start off at 0 with not a lot of height, and then as you grow, you get taller, but then as you get older, you slowly shrink. Now, I know it's not going to be back to 0, right? So these numbers are not great. But let's see, is there something else that does this? The shape of a ball when you throw it matches that, but I can't think of anything off the top of my head that creates that kind of a graph. It does look like a hill. Okay, so I want you to do 4, 5, 6, 7, and try to tell me, or try to answer those questions. Okay, so which one shows a linear association? And you can use A, B, C, D more than once.
Could it be more than one on each question?
That's what I was saying. You can use it more than once.
No, but like, could there be more than one on
Correct.
more than one answer?
Correct. There's 4 of them and 4 questions, and if you can use it more than once, that means there's more than one thing on a question. So, for example, B and C are both linear. Because if I drew a line or I drew a line, you could see that those data sets might form lines. Okay. Alexis, can you give me number 5, which are not linear, maybe? Okay. DNA. I don't think DNA is anywhere on here. Sorry, bad joke. The letter D and the letter A. Good job. Okay. Which scatter plot shows the weakest association? In other words, which one has the widest spread of data? Kobe? Just C, because it says weakest, right? Okay, and then which shows the most strong association is probably A. Okay. Great, so now try 8, 9, and 10 and line them up
What did
with,
they do to my pencil?
I don't know. Line them up with the one that it goes to. So it might be like that, and then like that. I don't know, I just put random lines. So 8 is gonna go with one of those, and then one of those is gonna go with one of those. So try to see if you can't figure out where they could match.
Can't even tell if this is positive.
Well, if you can't tell, then it might not be.
Not everything is you.
Yeah, there's 3 with the 5 options, so 2 of them options will not be used. Okay, so with number 8, Allison, which of the middle did you pick for number 8? No, number 8.
8.
Where did you draw your line for number 8?
No association.
Okay, no association, and I agree with that for number 8. It does not look like it's associated with anything. And then which of the 3 on the right did you connect with that?
I connected the temperature outside and the total gallons of gas.
Okay, I would agree with that. Temperature outside and total gallons of gas sold. I don't think they're related, but Once again, maybe you could make an argument that they are. Maybe you could say during the summer, more people buy gas because more people travel. I don't know if that's correct, but maybe you could do that, but we'd have to look at the actual data. Okay? Rylan, what about number 9? What'd you get?
Positive, linear.
Okay, positive and linear. And then which of the things on the right do you think goes with that?
Side of the home.
Yep, because the bigger the home, the more utilities will cost. Good. Okay, and then lastly, that only leaves us with 1, but we have to find the middle piece. So Landon, the middle piece goes with which one?
Negative and linear.
Negative and linear, and then that leaves us with only altitude. So think of this, altitude is the higher up you're hiking, right? And there's less oxygen in the air the higher up you go. So that's why it's decreasing, or it's a negative association. Okay, great. So any questions? Is it pretty straightforward? Okay.